The Chinese rover Zhurong explored Mars from 2021 to 2022 and discovered something significant. Zhurong gathered new evidence that the red planet, which today presents itself as a bitterly cold, dust-dry world, was once actually much more hospitable to life. And billions of years ago, it was home to a gigantic ocean. Today, we'll show you the exciting things China has discovered on Mars. So, be sure to stick around until the end if you want to know what valuable new insights the rover has gathered about our neighboring planet. Tianwen was supposed to achieve what Yinghua 1 had failed to do before. In fact, China's National Space Administration had been dreaming of sending its own space probe to Mars since 2011. More specifically, the small orbiter was supposed to set off for our neighboring planet together with Russia's Phobos Grunt mission. However, as the Russian launch vehicle did not even make it out of Earth's orbit, the ambitious Mars mission came to an abrupt end, and both probes burned up in the Earth's atmosphere in January 2012. This was an unfortunate incident that led China to decide to develop its own launch vehicles and carry out missions independently in the future. And at the end of this process, Tianwen 1 finally emerged. The name means question to heaven, and comes from a famous work by the ancient Chinese poet Yuan. Apart from these lyrical roots, Tianwen 1 consists of three main components: an orbiter, a landing module, and the Zhurong rover. Against this backdrop, the red planet was to be explored not only from orbit but also directly on the surface. And China actually became the first nation to launch such a trio to Mars in a single attempt and operate them successfully. On February 10, 2021, the moment had arrived, and Tianwen 1 reached the planet of desire after a flight lasting around 7 months. There, the orbiter began mapping and selecting possible landing sites for Zhurong. The landing itself took place on May 14, 2021, in the Utopia Planitia region, a vast plain in the northern hemisphere of Mars that was chosen as a destination because of its relatively flat topography and geological relevance. The actual scientific work could then begin to ensure its success. The orbiter, which weighs around 3 tons, was equipped with 7 scientific instruments. These included a high-resolution camera, ground radar, a spectrometer, a magnetometer, and a particle detector. The main task included large-scale mapping of the Martian surface and investigation of the climate, ionosphere, and local magnetic fields. The Zhurong rover weighs around 240 kilograms, is 2.6 m long, 2 m wide, and 1.85 m high, and owes its name to the Chinese god of fire. The 6-wheeled vehicle was powered entirely by solar energy, and its scientific payload consisted of a topographic camera, a multispectral camera, a ground radar, a magnetometer, a weather station, and a device for measuring the composition of the surface material. What Zhurong discovered on Mars during its mission from May 2021 to May 2022 was several significant scientific discoveries that greatly expanded our understanding of Mars, especially when it comes to water. As mentioned at the beginning, the red planet once had a slightly different face, and it's now considered certain that it was once adorned with lakes, rivers, and even a full-fledged ocean. And yet, the former Martian water is still shrouded in mystery because it is disputed how much liquid water there actually was and how long it remained there. However, the prevailing opinion is that there were no permanent liquid water sources on the planet's surface after a climate change 3.5 billion years ago. With the onset of the so-called Amazonian period 1.8 billion years ago, even the temporary water sources are thought to have disappeared for good. Well, at least that's what people thought, because Zhurong has actually uncovered a number of exciting clues that suggest the existence of significantly later Martian water. According to some theories, even in the frosty, dry modern era of Mars, water may have occasionally risen to the surface from hydrothermal sources or other groundwater deposits. This hypothesis is supported by, among other things, riverbeds that have eaten their way through younger rock layers. And while Zhurong took a comprehensive look at the morphology, mineralogy, surface structure, and ice distribution around its landing site, it provided experts with data that plays right into this theory. According to this, there are 2 different types of rock at the landing site. The first consists of dark basaltic chunks that probably originate from older, deeper layers, and the second consists of significantly lighter-colored rocks. Some of the darker chunks also have a light-colored coating, and the light-colored crust often appears flaky and peeled off, and according to analyses, dates back to the Amazonian period. However, spectroscopic investigations of the light-colored rock have shown that it contains hydrated minerals, and that is precisely the crucial factor. These are minerals that are water-bound in their structure, and which on Earth usually only form with the help of liquid water. According to the researchers, the spectral signatures of the Martian rock could correspond to those of hydrated silicates and sulfates as well as gypsum. Furthermore, based on the light-colored layers that are formed around some of the dark cores, they assume that these are a type of duricrust, hard crust that form when mineral precipitate from the poor water rock. In general, precipitation refers to the formation and separation of a solid substance from a solution, and when applied to the Martian crust, this means that it probably formed when salty brine rose from underground during periods of higher groundwater levels. Ultimately, the salt-rich mineral crust formed where evaporation from the nearby surface further increased the salt content of the poor water. In summary, the data collected by Zhurong suggests that groundwater existed near the surface during the Amazonian period. Possible causes for this unexpectedly late occurrence of liquid water include warming due to volcanic activity or temporary warm phases in the climate. The latter could in turn be attributed to the oscillating axis of Mars. This has, in fact, changed its orientation repeatedly over time, thereby also influencing regional solar radiation. On the trail of the Martian Sea, what is particularly exciting is that this discovery could also benefit us. Those responsible say that the landing site and other areas over the northern plains could contain significant amounts of usable water in the form of hydrated minerals and ice beneath the surface. This would be an important local resource for future visitors to Mars. But this was by no means the only discovery Zhurong made on the Red Planet. After all, there's also the Martian Ocean. Scientists suspect that the northern lowlands of the celestial body were covered by a shallow ocean until around 3.5 billion years ago. In detail, the ocean could have covered about 20% of the planet's surface. That's about as much as the Atlantic Ocean on Earth. The catch, however, was that for a long time, we only had circumstantial evidence collected by orbiters. Direct on-site evidence was lacking. But then came Zhurong. In fact, the rover's landing site is located about 500 and below and 280 kilometers north of the presumed coastline of the former Martian Sea. During its mission, the rover also passed the Visitas Borealis Formation, the sediment that was once part of the ancient seabed. It reached an area where the surface showed clear signs of former water activity. The sedimentary rock here had parallel layers with lens-shaped flow patterns and smaller channels and deposits. To find out more about these exciting traces, the experts used Zhurong's multispectral images and took a closer look at 23 of these formations and rock patterns. The result was exciting. The erosion traces found on the southern edge of Utopia Planitia indicate water exposure from two directions, which clearly distinguishes them from structures formed by river water or wind erosion. Experts from the Planetary Research Institute at Wuhan University of Geosciences say that since the grain sizes and deposit thicknesses are greater on one side of the ripples than on the other, this also suggests a stronger current in one direction than in the other. A brief explanation: the ripples mentioned refer to the wave-like surface structures on Earth. Such two-way currents are typically caused by the ebb and flow of the tides, which, in combination with the waves, cause the water to flow back and forth. But the Martian rock formations also resemble their counterparts in Earth's tidal zone in terms of shape and size. As a result, researchers consider the Zhurong discovery to be the most significant on-site evidence to date for the existence of a former Martian sea. At the same time, the data also provide important insights into its history. The observed tidal traces are located about 280 kilometers from the highest coastline of the ancient Martian Ocean and date back less than 3.6 billion years. At that time, the sea had probably already shrunk considerably, and the position of the sediment structures suggests that they were formed during a phase when the ocean was increasingly losing water and gradually disappearing. Zhurong itself has not yet disappeared, but unfortunately, it's no longer able to provide us with further insightful data. The rover was put into scheduled hibernation in May 2022 to survive the extremely low temperatures of the Martian night during winter in the northern hemisphere. The plan was to reactivate Zhurong in December, but it did not respond. Scientists suspect that too much dust accumulated on the solar panels during the winter, permanently interrupting the power supply. As a result, the mission was officially declared over. However, strictly speaking, Tianwen 1 was only intended to be the start of further ambitious programs. While Tianwen 2 is currently on its way to the near-Earth asteroid Camolula, Tianwen 3 is even set to bring material sample from Mars to Earth for the first time. And now you're welcome to click on the thumbnail to subscribe. Simply become part of our community so you never miss a new video from us. See you soon.